All this is going to be available to you later. I think I'm going to save this as a PDF and send it to everyone. And like I said, this is already being recorded, so you'll have access to this. Just give you a fair warning, if I get disconnected for whatever particular reason, I'll sign on as quickly as I can. So don't freak out if you see me bounce. But with that being said, my name is James Costanella. I've been a Codementor for about 6 months. I got my undergrad degree in computer engineering, and I just recently got a graduate degree in data analytics. I started programming way back in the day, C and C++. Now I'm basically sticking with Python. I'm also currently using Docker a lot for my development projects. So I think it's forced me to standardize the way I think about how I approach a lot of things. Let me think. There's a new person here. Hi, Sultan.
Hey, man, how you doing?
Good. How are you?
I'm okay.
Just as a heads up, let's keep the mic muted throughout the session, and you can use the chat window for asking questions and all that. So that's an introduction to who I am, and here's what I'm going to try to cover in this session. Basically, what I'm intending to do is give like a brief overview of Docker and how it works and how I use it for development. Right? We're going to go over a brief overview of what Docker is, containers, and how they work. I'm assuming everyone here has some experience with Docker, but if not, hopefully I'll go over the basics enough, and then I'll show you sort of like my opinionated way of how I do development with Docker, using custom Docker files for the application and Docker Compose to sort of tie things together. All right. So with that, let's get started with the Docker introduction. Right. So first things first, what is Docker? Right. So I basically stole a bunch of quotes from their webpage. Docker provides a way to run applications, and I'm going to insert something here. In terms of applications, think process, right? Any process on a Linux machine can be wrapped up into a Docker container, right? So the whole point is you take this application or this process, and you package it up into a single unit that has all its dependencies and all its libraries into that single unit. And it's that single unit that we call a container. Right? Now, one of the advantages is that, because you're going to run your application from the point of view of Docker, you always have the same environment. Assuming you're always using the same Docker version and all that. And this is one of the reasons why I like to force Docker into my workflow, is that it forces my development environment to be basically the same exact thing as the production environment. Right? And the way I view things is that the containers, Docker basically provides an environment for running these containers, where each of these containers is essentially a building block for software. Okay. Feel free to, again, as I go through, if you have any questions, just pipe up in the chat room. Right. So what is Docker as compared to virtual machines? I see this comparison a lot. Containers are essentially just a lightweight virtualization. So with virtual machines, each thing that you're virtualizing is an operating system plus the binaries and your applications, right? Docker takes out the guest OS part, and that's the main difference between this and virtual machines. Here, through the Docker engine that's running on a host operating system, you can run different applications or processes by themselves without this extra layer of a guest OS. And that's why they call it lightweight. There's an extra layer that you're taking out. And in some sense, basically, Docker is a way of doing process-level virtualization. Before I go any further, does this make sense before I jump any further into this? I'll assume silence means we're good. All right. So what is a container exactly? Right. This is the core of Docker, right? The idea of a container, right? The container is really just a wrapped up piece of software with a complete file system that it needs to run, with everything that it needs to run. So your container is going to have the code for the process. It's going to have any runtime system tools or system libraries that it's going to need in order to run. All the things that you need, any networking ports that it needs, is going to be wrapped up into this container, right, in this single unit. This guarantees that they are always going to run the same, because every time the process runs, it's running in its own little world, its own little container that has a complete file system that is always the same, right? This allows us to treat the process and its dependencies as a single unit, right? And it's this unit that we're going to use as our unit that we ship around to our Docker machines. All right, so that's our basic unit. I hope that makes sense. But here's a little diagram that I hope makes things a little more. Sultan, do you have a question? You know what? I'll try to keep this here so I can see it. Okay, great. Awesome. So if you think about a textbook process, right, and literally from like an operating system's textbook, you know a process is basically this code here. PGM is a program code, memory for the random access memory that it requires as it's running. And if you really want to get nerdy, CPU registers in a process table from Linux. But generally speaking, this is what a textbook process looks like, right? And in the real world, when you're running a process, there's a lot of things that are pointing to stuff on the file system. For example, this portion of the program code refers to the actual binary of the process, whatever it might be. Part of it, though, is going to be shared libraries from the system. And another part of it is going to be configuration files from Etsy, right? And notice how in the real world, on your operating system, right as it stands, the process points to all these resources on a shared hard drive. The whole point of the container, though, is to bring this inside the container and to wrap it up into a nice little unit. And notice how we add a little block here for networking. So each container has access to a network. Okay? So basically, the idea of a container is to extend this boundary to include all of its file system dependencies. And if you want to get advanced, you can use containers to also tune limits on these resources. So you can limit how much networking this container can do, how much access it has to hard drive resources, etc. The next diagram I'm going to show might be a little confusing. I would say, generally speaking, as long as you get the general idea, you're okay. What I'm trying to show here is the general idea of what we call a state machine. Any container that is instantiated, it could be in 5 states. It could be created, right? So it exists, and then it's running, so the actual process is running. You can then pause that process, just like you can pause a process in Linux or Windows or the Mac. You can then stop that process, and you can then delete that container, right? So the 5 states are very similar to the process states. If this is confusing, I would suggest that you don't worry about it too much. But the general idea is that for our container, it has a life cycle where first it's created, and then you run a command like docker start to start the container. You can stop it, you can pause it, or you can delete it from there. Okay, so why care about all this, right? What is the purpose behind all this? One of the reasons I like Docker is that it does force you to break up your application from the get-go into simple parts. And for me, it helps keep the cognitive load on your brain a little lower. So instead of dealing with one big application and remembering how it all interconnects, and then, God forbid, you have to work with other people and you have to share this documentation with people, instead of doing that, you can just break into these small pieces and then orchestrate these small pieces, right? It's easier to document how to build and configure your software, because at the end of the day, software is just not code. It's code that runs inside of an environment. And you do have to worry about this environment, right? Something I mentioned before was if you use Docker for development and you also use it for production, you basically now have identical stacks. And there's none of this, oh no, the code works for me on my computer, but it doesn't work for you when it's in production. If you keep your stacks the same, you're going to get less of those issues, right? But if there's one thing that I've personally benefited from the most, I would say is this notion here that basically, later in this talk, we're going to talk about how we can use Redis very easily in our little application that we're going to write. However, before Docker, what I would have had to have done is download and install Redis myself on my laptop, which in and of itself is a problem. There's shared libraries I need. Some of those shared libraries need to be updated. But the most important thing is that Redis installation is now really very tightly linked to my operating system on my laptop that I'm hosting this from. That's not good. If I upgrade my operating system, it may upgrade Redis for me, and now all of a sudden I'm running a different version of Redis than that's running in production, right? So Docker gives you a nice way of keeping that separate. I don't know if any of you use the Mac OS X for your development, but I have in the past, and it's really a pain. I mean, it's really a pain. You have to use, what is it called? Mac ports sometimes to install things, and then you have to upgrade it through there. I found it to be a hassle. Where with Docker, hopefully you'll see later, when we install Redis, it's literally like a few lines of code. Anyway, I'll stop yapping about why this is useful. Let's quickly go over the Docker vocabulary. Right? We've gone over what a container is. At the end of the day, a container is really just a process grouped together with a bunch of dependencies. Right? What is an image? An image is a blueprint for creating containers. For any of you who have done programming, this is basically the class versus object distinction, right? Or a virtual machine image versus an instantiated virtual machine, right? So just like we're going to see later, there's a Redis Docker image that someone created, and then allows me to create one or more of these containers on my actual machine, all right? A Docker file is simply a text file that gives instructions for building these images. The Docker registry is basically an external service that allows you to store these images at a third party that allows you and your production systems or other developers to have a common place to store your images. All right, and the other notion that is going to be very important later on is the notion of a volume. A volume is very much like a traditional Linux or Unix mount. At the end of the day, a volume is simply just a folder on your host system that you want to make available inside the running container. All right, so a volume is like one way to connect your running container to your local environment. And then the last slide here, I think I have, or the last couple of slides I have, the Docker ecosystem. I'm going to talk more about the tools that are part of the Docker system, right? This is just terminology. And here's some of the tools that we're going to eventually use. Docker Engine is basically the core of Docker. This is the daemon that presents a REST API and is responsible for actually running containers, right? And when you work with Docker on the command line, this is what your interface can do. Docker machine is essentially a virtual machine running a Docker engine. Now, you might be saying, well, why can't I just install Engine myself? I can, and we're going to see this issue later. I can because I'm running Linux right now. I'm on Ubuntu right here on my machine. I can install Docker easily. But if you're running Windows or Mac OS X, you can't. And you need a virtual machine. And so I decided to do this talk from the point of view of a Docker machine to make it easier for people who are on Windows and Mac OS X to understand what I'm doing. Docker Swarm is, in some sense, a way of orchestrating multiple machines in a distributed, fault-resistant way. Sadly, we're not going to get to Swarm in this talk, though I think my next talk in Codementor is going to be about Swarm and how you can set it up. Hopefully I'll get around to that in the next couple of weeks. Docker Compose is the tool that we're going to use today to coordinate multiple containers and how to run those containers on engines. Right? So I'm going to provide a little diagram here that I hope makes things a little clearer. Here we have what we call Docker host is equivalent to a Docker machine. It's a virtual machine. I'll show you running it on VirtualBox. That's what I'm going to implement it on. Inside the Docker machine is the Docker daemon, or what we call Docker engine now. This is what's actually responsible for running containers. And all the client commands that we're going to run over here interface to this daemon or this engine. And that engine is responsible for downloading images and instantiating containers from that image. All right? So let me take a quick pause here for questions. And I need to do basically about a minute per slide, so I know I'm already behind. But does anyone have any questions? Yeah, Homebrew. Yeah, Homebrew is I don't know, it's rough, man. I've never been able to get it to work very well. And over time, it starts to become problematic. But does anyone have any questions about the the Docker environment or any of these terms that I've used, this thing's out. Yeah, we're going to get into the VirtualBox. So we'll move on to that, actually, I think, in the next 3 or 4 slides. Ugh, I don't know what's going on my screen. So I don't necessarily need to use a VM because I'm running Linux. But I imagine when I was doing all this, I imagined that a lot of people were going to be using Windows and Mac OS X. And because those kernels don't provide what's needed, your Mac OS X users and Windows users have to use a VM. So I don't have to, but everyone else would. So I figured there might be a disconnect. So I'm going to force myself to use a virtual machine, just so everyone else can see how you would do it on a Windows. So, oh, there is native Docker. See, I could have sworn the native Docker. If the native Docker is still using Docker machine, all it's doing is wrapping around boot to Docker, which is still kind of a small virtual machine, as far as I understand, and maybe I'm wrong. But generally speaking, if you don't have to use a machine, all these commands will still work. You would just, instead of using Docker machine, you would just use the native commands. So if anything, it would just be easier. So we'll see how everything works with the machine, and then I think it'll become clear how to use it without. All right, so like I said, these are tools we're going to be using: Engine, Machine, and Compose. And we're also going to be using VirtualBox. And Swarm we'll use later in another future presentation. Here I give some install notes. I'm under no, there's no way I can force everyone to keep a pace in just an hour. So, oh, the Ubuntu's now, yeah, Docker Toolbox, okay. Yeah, so I still think at the end of the day, OS X is still using like a mini virtual machine, but I could be wrong. Either way, I provide some links here that you'll have access to install Machine and Compose and VirtualBox. Like I said, I imagine people are not going to be keeping pace with this. So, yeah, when you view the recording, you can come back and install everything. All right. So here we're going to jump into an example, and I'm going to start showing you how I do things. Right. So let's pretend like I was hired or you're hired as a consultant to build a small REST API. Now, personally, I'm choosing Python and Flask to do this. You can use other stacks as well. I think they'll work just as well. So yeah, this talk is a little opinionated in how I set things up and what I use, but hopefully this should be applicable to other languages. We're going to call this application Flask Tester, and you can view the GitHub repos that I created for the code itself, and for the Docker sort of environment that I'm instantiating. So I split. As a matter of fact, in the next slide, I start off with, I like to keep multiple repositories for any given application I'm working on. One for the actual source code itself, and another for basically orchestrating that application using Docker. I think this actually, in some cases, poses a little bit of a problem. If you want to keep everything in a single repository, I've seen people do that too. Again, this is just my way of doing things. So, again, when you're following on, these are the commands you would run to clone the code that I have for this example. All right. Here's a quick overview of my Flask application as it stands, as it stands right now. If you guys don't understand Python, I apologize, but the general idea is that I'm hosting a REST API. It allows for a GET at the root URL, and all it does is return a hello world. Right, nothing too crazy, right? Later on, we're going to see how we can integrate Redis into this. 2 tips that I'll give you that are applicable to your applications that you want to Dockerize, that are general enough that it's not specific to Python. The first one is you should make your application respond to environment variables, and the way I use it is for configuration loading. So I'll have multiple configuration classes, and then I'll have code to check environment variables for which configuration I should be loading. This allows you to have the same code in your Git repository, but have that code be responsive to your Docker environment, where the Docker environment can tweak the environment variables. I'm not going to do that for this example, simply because I think this is going to get complicated. And the second tip is when you're doing development, whatever environment you work with, you want to make sure you have your application change when your source changes. Now, I'm going to show you how I do that from USGI. You'll have to figure out how to do that for your own applications. But it's tough to do development if you're not seeing live code changes. All right. Let me quickly go over the workflow I do when I'm doing these things, and we'll take a pause and we'll talk real quick about the workflow. So the first thing that I do is I create a Docker machine to host my Docker engine. Now, like I said before, I'm on Linux, so I have Docker engine installed locally. I don't need a VM, but I figured to make this applicable to more people that I'd use a VM instead. To make this as general as possible. So that my first step is either to get a Docker machine or at minimum get Docker engine running on my machine, right? Then we're going to create an image for a container that's going to host my Python application. Basically, it's going to host this little Python application here, right? We're then going to figure out what volumes this container is going to need for the source code and any configuration that it needs. We're then going to write a compose file to allow it to automate the creation and deletion of this application. And then I'm going to write some scripts to sort of wrap around those compose commands to make my life a little easier. Right? So that's my general outline for when I approach an application. All right. So before I go into the commands, let me just pause. Does anyone have any questions? Is everyone following my thinking here? All right. I'll assume silence is good so far. Great. So let's start with the first step. How do we first create a machine? Well, once you have Docker machine installed, it's as simple as saying create. You pass it the driver that you want. In our case, it's going to be VirtualBox. I'll show you later on. Hopefully, I think we're going to probably run out of time, but hopefully we'll see how we can use this to do a Docker machine on DigitalOcean. And I'm going to give it a name, Flask Tester Engine. You could have called it Flask Tester Local or whatever you like, but that's the name of the machine. Once you do that, you can list out the machines, and then you run this command to make that machine be the official machine you work with when you're doing Docker commands. And then we'll run a Docker command to see it in action. So let's do this live. Right? First things first, I've already created the machine. So, because I'm not going to waste time doing that here. But as you can see here, I have a thing called Flask Tester Engine. The star here means it's active. It's my VirtualBox. It's running on this IP address, and that's the Docker version. Okay? Since it's already active, I don't have to do this next command, but we'll do it anyways. This is how you make this machine active. Oops. Now that's my active Docker machine. Any Docker command is now going to be in reference to that machine. Now, if you notice, I already have some containers running, so I'm actually going to go ahead and stop that. And this is just a wrapper to compose. We'll see how this works in a second. But just to keep pace with this presentation, we'll see that there's no containers. Oh, excuse me. So we'll see there's no containers right now running on this machine. So what I want to show you here is basically a little diagram of what we have so far. What we have is a virtual machine with our Docker engine that my Docker command line is talking to. And this is my local file system of the code. I have one for, the back end being the actual application, and Docker being everything I have related to my Docker orchestration. Okay? Now here comes a problem. Basically, the file system I have here is independent of the machine over here, and this is why things get really complicated. It's a little confusing when you're using virtual machines. You have to figure out how to make this mount work. Basically, you want your engine to somehow have access to this code. So how do we do that? Well, first we set up, basically Docker machine sets up what we call a shared VirtualBox volume by default. I personally don't like the way it does the automatic mounting. So here's the command you use to tell this this virtual machine to auto mount this folder, and this is my local folder. Your folder would be different to the virtual machine. And once you run that command, if you go to settings, and you can do this in the GUI if you want, you'll see that there's now a shared path. This is the path to the root of my code for those two repositories, and it's auto-mounted. You can do this through the GUI. Later on, you'll see that I had this in a script, so you don't have to remember this too much. And you only have to do this once, is the key. You only need to do this when you first set up the machine. The next cool thing is that you're going to use Docker machine SSH to SSH into your virtual machine and run this command, these two commands, which is going to create the mount code folder, and then we're going to tell the virtual machine to mount that shared folder. And then once you run this, you'll see that indeed inside the virtual machine, you'll see access to these two things that are right here local. Excuse me. See how these are the same? This is on my local machine. This is from the point of view of the virtual machine. And I think the diagram will make this a little clearer. So inside the virtual box now you have a folder called mount, which is basically just a mount from my local file system. So now Docker Engine has access to everything here. Okay? All right, so that's the end of the first step. Let me just poll. Is everyone clear with that? I know that's probably a little painful, but for Windows users, since you're going to have to use a virtual machine, you're going to have to figure out how to do that. I think the same for Mac OS X. Yeah, if you have a native Docker, I say use native Docker. I think it's probably a little easier. Only thing I maybe say is if you're working on a lot of consulting gigs, maybe you want to keep things separate. But I don't think there's any advantage outside of the fact that eventually, when you do this in production, you're going to use another Docker machine. Hopefully, that we can get to if we speed this up a bit. That way, in some sense, when you're doing development and you're doing production, you're using the same commands. That would be one advantage. But if you have native Docker, I would say stick with it. Does that answer your question, Team Max? And just for the recording, let me just repeat the question. The question was, are there any reasons or advantages to using Docker machine if you have a native Docker? And I just gave the answer. So we'll move on from there. So the next step is I have to think to myself, well, I want to create an image for this for my Python process. All this is a Python running in a process. That's all my application is, right? Now, if you're used to the well, actually, before I get into that, when you're thinking about creating an image, you need the question you need to ask yourself is, what are my dependencies? What does my Python process depend on? Well, before we get into that, we should also think, well, what is my main process? And like I said here, my main process for this container is new WSGI. If you know Python, you know what that is. If you don't know the Python environment, that basically is a program that will run this code and allow it essentially to have multiple threads and watch after that process. And so it's basically a way of orchestrating this Python process, right? So that new WSGI process is going to be my main process for the container. And what are the dependencies? Well, I have a dependency obviously on the source code itself. I'm going to have a dependency on the new WSGI binary and any configuration files it needs. And I'm also going to need a port 80 for client communications, right? So I always want you to step back and think of those terms, right? Think of those terms of what the dependencies are. Now, I would have liked to have gone into like a little discussion about Fusion Base Image. Fusion Base Image is a nice way of creating Docker images that has some bells and whistles. However, it goes against the traditional philosophy that your container should have one process. in Fusion base image, you actually have a few processes to help with logging and syslog and cron and stuff like that. I think it's neat, but we're going to skip it, and I think we'll get into it in the next session. The main idea is that, given our base image, and the base image I'm going to use is just a standard Ubuntu image. What that means is essentially my container is going to have like a standard Ubuntu file system, right? And given this base image, I now have to think, well, how do I get my dependencies in there? Right? So how do I get my dependencies in here? Well, what we need to do is create a Docker file. A Docker file is a text file that describes how to build an image. So I'm going to say, and I am going to rush through this a little bit because we are actually a little pressed for time. I'm going to build this from the base Ubuntu image. I'm going to tell the Ubuntu file system, I want you to update with the latest packages. And, well, what's one of my dependencies? I need Python, obviously. Ubuntu doesn't come with Python, so I need to install it. And the setup tools, because that's what's going to install this thing. Easy install. I then tell the container I need pip installed. And then from there, I also tell the container run the pip command to install new WSGI and Flask. Because these are the two Python libraries I need in order to run my code. I will definitely share the slide, yep. And also share the recording as well. Right? If you also remember, I need to tell Docker that this needs a networking port 80. And then this last thing, the CMD instruction tells the Docker that my container is going to run this process as its main process. Remember, every container has to have wrapping at least one process, right? So MuSGI is going to be my main process, and these are the parameters that I have to give as a quoted list. I want it to open up a port 80. I want MuSGI to run this as my source code, and we'll talk about how to get this to work. And this is how you get it to auto reload. So anytime it detects a code change, it'll automatically update and refresh itself. All right? So that's the Docker file that needs to be built. Well, how do we do that? Well, inside my Docker repo, I create a folder called images flash tester. And let me see if I can pull that up real quick. So inside my Docker code, I have a folder now called images. My first image is going to be the flash tester image, and there's a Docker file inside there. Right? And the Docker file, it's a little more updated than what we saw before, but it's generally what I had in the slide. You'll see changes to it later. So I create that directory, I update the Docker file, and this is the command you need to run. This says I want to build a Docker file. I want to give it a name, and this is important. Every Docker image has a name and a tag. The name I'm giving it is flash tester, and the tag I'm giving it is 0.1 just to give it like a version number. I hope that makes sense. And from here, and this is one of the reasons I'm not doing this live, is because this takes a while. It takes a few minutes, nothing too major, but it does take a little bit. So let me jump to the code here, and we can see that when I run Docker images, and again, this is running with respect to my Docker virtual machine. You'll see I have quite a few now, but I have one image called flash tester. Now, right now, in the slides, is version 0.1. That's the tag. It has an ID, and that's my new image that I just created from the Docker file in this folder. Notice you don't have to give the exact path to the Docker file. You have to give the parent folder. It's a little bit of a quirk, but that's how it is. All right? So each image is identified by name and a tag, and I just created it. I hope that makes sense. Now we're going to take. Now that we've created this image, we have to say to ourselves, well, how am I getting the source code and any configuration files I need into this image? Now, I don't like copying source code into the images because it's not flexible. Anytime I change my code locally, I want it to appear in the container. So if I want to do that, it's better to mount it as a volume. So when you mount things as volume, you're going to do that when you run the container, not when you create the image. So we're gonna see in the next slide, the next couple slides, how we do this. How do we mount our source code as a volume? Now, I'm putting this here. I don't have any config files right now, but normally I would have config files from USGI, and I would also do that as a mount, and for the same exact reasons. If I want to change the configuration on the fly, it needs to be local. I don't want to keep building the same image just to test the new configuration. I want it to be a little more dynamic than that. So anytime you want that kind of dynamic nature, you want to use a volume. Right? So here we're going to take a brief interlude, and we're going to prove that we can run this container. So here I'm telling Docker to run in daemon mode. I'm going to give it a name called Flask test container. I want to have the port 80 inside the container to map to port 80 on the virtual machine. And this is how we do the volume mounting. And this is where it gets a little quirky, especially when you're using virtual machines. This is and I put the note here, this is in reference to the virtual machine. If you remember, the virtual machine has our code as under mount code. And I'm going to show you how this looks in a diagram in a second. But I'm telling you, from the virtual machine, take this folder and mount it here inside the container. And that's how we do the source code volume mount. So we can run this. At least I think I can. We'll see if it works. All right. You'll now see that it's running. It's running this image. It's going port 80 to port 80. That means, if I got this right, now, since I actually changed the source code, that's actually not going to work. But in this case, if you did this is essentially what the situation now looks like. I've created a container that's mounting this folder inside the virtual machine, but this folder comes from the shared mount, so it's as effectively as if it was mounting my local code. That's what that dotted line means. Is everyone following so far? Okay. Moving on. I know I didn't prove that worked, but that's because I changed the source code at the last minute. So basically, now our next step. So now that we proved that it works using the run command, now we can say to ourselves, well, you know what? I'm not going to remember how to run this. There's a lot of flags here. But what's cool is that for everything that you see in this command line, you can write in a text file called a compose file. And we're going to see how that works now. That's our fourth step in our little workflow here. Is basically, I want to automate the orchestration of these containers, right? So what I'm going to do is I'm going to create a text file called the compose file. And it's that file that's now going to create these let me just stop this Docker this container, and we'll remove it. Excuse me. Just to make sure everything's cleared. Okay. So now, let me show you the compose. So this is the compose file. It's on GitHub. You can follow the link, but this is the main part of the compose file we need to care about. If you're not used to YAML, YML, Docker will probably be a little confusing, but YAML is another markup language that's basically used throughout Ruby and Docker. There used to be an old version of this called version 1. Don't use version 1 anymore. It's basically been deprecated. Just forget it. Always use version 2. Right? So the first thing we're saying here is we're using the Docker Compose version 2 syntax. And then all your containers are essentially under the services tag. And the only service right now that we have is our single container that we have. I give it a name. I tell it what image to use. I tell it how to mount the source code as a volume, and I tell it how to open up the port. Notice, all 4 of those things I just outlined outside of the host name appear in the run command. Right? The port, the name, the volume mount, and the image to use. Right? So you can think of Compose as really just a fancy way of doing Docker run. That's the way I view it. And the reason why it comes in handy is when you have multiple containers, which we'll see hopefully in the next 5 to 10 minutes, right? So here's how we bring up our application now. You would run this, you say docker compose, use this compose YAML file, which is, I think I closed it. In the doc, if you go to the Git repo, you'll see under compose. Right now, we're working with this one, basically this, and that's where it is in the repo. And as you tell it with the -f flag, that's where the YAML file is. You say up -d says bring up all the containers. The -p local is not so useful, but basically you can give your compose containers a project name. And the reason that only comes in handy is when you do automatic naming. I'm not using automatic naming, so you can actually leave that off if you want. But once you bring it up, actually we'll do that right now. Once you bring it up. Right. Ignore this thing about Redis for the time being. That's what we're going to do in the next 5 or 10 minutes. But now that you've used compose to bring it up, you can ask compose, give me a list of all the containers that are running. And here, these are all the containers that are now running. Again, there's 2 because it's running the latest thing. So using the example we've done so far, it would have brought up this Flask tester. Right? And the same exact containers you can see using all. Right? It just gives it to you in a different format. And if you want to bring everything down, you just do this command to bring it all down. And now everything's finito. All right, and so actually, no, let me bring it back up. Now that I showed you how to do that, let's bring it back up. I'm going to hope that this works. Let's see. Okay, so in the latest source code, I'm using a thing called Redis, but this is the output basically from our little web application. This is the IP address of the virtual machine. How do you get that? By using this command, docker IP. Excuse me. Whoops. Engine. Right. So if you do this docker machine IP address IP command, it gives you the IP address, and port 80 is open to our application, so that now our application is running on this virtual machine. Does that make sense so far? If you have any questions, now's the time to pipe up. But one thing I want to get into before we move on is excuse me. I want to move on to the Redis. Adding Redis to this. Let me just show you my workflow for how I added a new container. So originally we had a single container, but then I updated my source code because my application needs to use Redis for some reason. But now my application now is in really 2 building blocks. One, my application block, and now Redis as its own independent block of my application, right? Redis, as you haven't heard of it, is a NoSQL type database. And what we need to do now is I first have to update the Docker file because my Python code now needs the Redis Python library. So first I have to update that. I now need to create a new container to house the Redis process, because Redis is itself its own process, therefore it's another container. And then we need to update our compose file to link them together. So let me show you the changes I made to do all those 3 things. So this is now the updated source code to my application. Notice I have to do an import Redis, so therefore again I have a new dependency. I have to import the Redis library. And then I connect to Redis, and here is an important point. How is it connecting to the Redis container? Because it has to be communication now between these 2 containers. My Python application has to talk to the Redis database, right? Again, this is just a basic REST API, and all I do is I increment the counter, and I print it out. And that's why we're seeing 21. If I reload it, you'll see 22, 23, 24, right? So all this data is coming from Redis. So what does the compose file now look like? Right? So I've updated, the Docker file. I've now updated, my source code. Now I need to update the Docker file. So let's go to the Docker file if I can find it. My Docker file now has this so this is the way it used to be. I just now have to tell pip I need to install the Redis library. You go through the building of a new image, and the important point is you give it a new tag. Now the tag will be 0.2 because this is a new version of this image. All right. So first I updated my source code, and because now my application now has a new dependency, I have to update the Docker file to update the image. Now that I'm using a new image, and now that I'm using another container, I need to update my compose file. So now my compose file is made up of two things. This is the application container, but now I have a new container called Redis. Well, where did I get this image from? Where did I get this container from? I didn't create a new image. Where this is coming from is a thing called Docker Hub. If you remember back from one of the previous slides, I introduced this notion of a registry, which is a third party or independent service that can store my images for me. Now, in this case, I'm using a thing called Docker Hub, which is provided for me by the people who created Docker. So it's a public registry at the end of the day, and the people at Redis were nice enough to create their own container. And this is where you can find it. So the only thing I have to do is literally reference the Redis image name and a particular tag. Notice the tag names give you the version number of Redis. In this case, I want to use the latest, so I use 3.2.5. As a good rule of thumb, you should always explicitly use version numbers. That way, later on, you don't accidentally upgrade Redis. So here I'm telling Compose, I have a new container that I want. I want them to use the public Redis image that's available to everyone. I want to give it a name. And specifically, and this is this is a little wonky. If you go to the instructions here, to tell Redis that you want to permanently store data on the hard drive, you have to give it a certain parameter. So I'm telling Docker Compose, when you create this container, the process should not only be the Redis server, but I need to give it a special flag. Append only yes. That tells Redis to store data onto the hard drive. And if I want to store data permanently, I need to mount this as a volume. And again, from the instructions here, it tells you how to start with persistent storage. You need a volume mounted under the /data folder in the container. So here again, I'm referencing a folder that Docker will create on the virtual machine, and I tell it to mount inside the container at /data. Redis will automatically write to that folder, and therefore it's writing to my virtual machine, and therefore it's permanent. Meaning, if I destroy this container and recreate it, and I'll show you how that works, it'll still maintain the database. And you have to tell Docker that this container wants this networking port. So again, if you think from the point of view of dependencies, I need the Redis server process needs to run and needs to know to permanently store data. This container automatically stores things in data, so I mount it as a volume, and it also needs a networking port. Those are all the dependencies I need for this container. And now, when I do Docker Compose up, like you saw before, after I did up, it actually creates two containers. See? Flask Tester and Flask Tester Redis. Now, I do need to start wrapping up. So the main thing I want to get across with these two containers is that persistent volume idea, which I hope makes sense. And I want to get across this other idea that they're basically networking together. How are they networked? Well, here's a cool little thing. There's a command called docker exec that will say, I want to execute this command inside this container. This allows me to run a bash shell inside the container so I can do debugging, right? So let me jump into it. Notice my prompt changes. I am now the root user, and notice the host name is Flask Tester because I said so in the compose file. And now, if you go back to the compose file, which is here, I could, from this container, I could contact this container either using the service name or the container name. So I can literally just say ping Redis, and they can ping each other. Or you can use the container name. Well, actually, I think the host name. Whoops, excuse me. All right. As an internal IP address, you don't have to worry about it. But the point is, one container can talk to the other container, and that's why this code works. My updated code. My updated code works because I'm telling it to contact the Redis server, where that resolves to the other container. So that's how we get the networking to work between the two containers. And to prove to you that if I were to take this down, remember, I'm going to cross my fingers, I hope this works. The counter is at 24. If I bring this down, which is going to not only shut down the container, it's going to delete the containers. But because we're using persistent volumes that exist on the virtual machine, those volumes don't get deleted. They'll just get remounted. So now if I restart the application from scratch, cross my fingers, this should say 25. There you go, 25. I just completely restarted the application, but the data was persistent. All right, and I hate to say this, I only have 5 more minutes, and I do have another meeting right at 7 o'clock, so I do have to get going. So let me stop here. I basically am going to stop at this step here. All the commands that I wrote, let me just show this real quick, I put into scripts. Let's see if I have it here anywhere. Under the scripts folder, you have now a bunch of basically one-liners like stop the application, is just a wrapper around the compose script. Right? That's the up command, shut it down. There's a couple other scripts I did to remember the commands you did for mounting on the virtual machine. Those are wrapped up too. And since I can't really get to extending this to well, here's what I do. I won't do it live, but I'll show it to you in the slides. What you can do now is you can scale to the cloud. Oh, the -p local. Yeah, let me quickly get to that. So in Compose, the -p gives it like a project name. P stands for project name. You don't really have to use it, but basically, if you didn't give explicit names to your containers, Compose is going to create names, and it would use a project name. So you can use a project name just to make sure your containers don't have the same names, essentially. But I like to name anything myself, so it's not really that useful. I'm glad you learned something. Let me just quickly go over how to scale this to like a production cloud environment. All you have to do is create now another machine, and you can use a different driver like DigitalOcean. So in my I created a script. I didn't save it to the repo because it would have my own API keys. But this is just a wrapper around this command where you give your own API key in this part over here. And then all you have to do is switch that machine using the eval. And that way you're now using that machine. However, there's a big issue here. And the big issue here is volumes. If you create a server in the cloud, that machine has no idea how to get the source code because the source code is on your local machine. It gets a little wonky, and I wanted to do this a little more in depth. So I think what I'll do is this is where I'm going to cut it, but I'll make basically a new presentation, part 2 of this, and I'll explain how you can do this in the cloud and then how you can start scaling up with Swarm. So if you like this presentation, I hope you did. Look for a new one, and you'll see a continuation of this, of how you can then use provision this in the cloud. I like doing this in sense of doing like an MVP or doing like a client demo. If you're going to do real production work, you really want to use something like Swarm because it's fault tolerant and all that fun stuff, even though it's certainly a lot more work to set up. But if you're doing like a quick demo or even like an MVP, using something like this can work. The main way of fixing this volume issue is that we have to update our Docker file to store our source code in the actual image. But then the problem is we need to store this image in a third-party registry. So on Amazon, I put a link onto how to set this up, but basically in Amazon, if you have an account, you go to the ECR service, EC2 container service, and then you can create a thing called a repository. And when you create the repository, it gives you instructions on how you can push an image to that repository. I really wish I could do this a little more in depth, but I think what I'll do is I'll write up some more slides, and we'll do this as another office hours at some point. But so that's the general gist of it, right? So we have to create a new image with the source code baked into it, and then we gotta push that to a registry, and then change the compose file to point to that registry. So let me show you real quick what that compose file would look like. Notice I have a separate compose file called prod, meaning this would be more for production, or maybe like a minimal viable product and all that. You still have the same exact stuff. The only thing that changes is the image. So here I'm using an image instead of using my local Flask tester app with the number. I had this prefix which tells it to use my Amazon AWS registry. And that's pretty much it. Once you get the image pushed there, the Docker machine that's on DigitalOcean will know how to pull this down. And I actually did get this working. If you see here, this is an actual public IP address. You should be able to hit it yourself if you want to, if you so desire. But if you reload it, you'll see that it works. But yeah, that's pretty much it for the time being. I hope you guys, if you have any more questions, you can always contact me on Codementor, and I'm always happy to so I think someone was mentioning before that they were trying things and it wasn't working very well. So if you have any problems with it, let me know, and we can maybe fix up your environment. Or yeah, I think you should be getting a notification hopefully in the future, and hopefully maybe next week, maybe next Wednesday, I'll have something cooked up for how to do Swarm and all that fun stuff. All right. If you have any other questions before we go, 7 o'clock, do you have any more questions? Thank you. I appreciate that, T-Max. Much appreciated. And same to you, Sultan. This was actually my first time. That's good. Where are the slides? I have them on Google Docs, so I think I have to talk to the people at Codementor who organize this, and I'll give them a link to it, and they're going to be responsible for sending out the slides and the recording. But yeah, they should be in contact with you with. I wish this Zoom interface would work over there. Thanks, man, Sultan. I appreciate that, man. I really do appreciate that. Yeah, just let me know if you have any other questions. If not, we'll call it a day.